When astronauts first explored the moon, acquiring lunar samples for study from mostly flat terrain was easy. They could simply pick up a moon rock. But that's not the case when it comes to investigating other celestial bodies, like the rugged surface of Mars or asteroids coming dangerously close to Earth. Luckily, new innovations in space robotic technology could soon change all that.
There are lots of places we can't get to in the solar system right now. The rovers we have on Mars are really good at driving around on the flat ground, but if we want to climb on cliff faces, if we want to grab onto things in microgravity, like on the surface of an asteroid, we don't have the technology to do that. And our grippers are designed to enable the robots to go where gravity is working against you or isn't there at all.
I headed to NASA's Jet Propulsion Lab in Pasadena, California to meet Aaron Parnes, Extreme Environment Robotics lead, to learn how common hooks are the key to their cutting-edge micro-grippers.
So it looks like hooks here are the key to the magic.
That's right. That's what actually grips onto the rock.
How did you find the right hook?
We were actually inspired by insects. If you look at the leg of a cockroach, it's got lots of sharp spines hanging off of it. Those are opportunistics, and those spines catch and help the cockroach, run up the wall. And so our grippers use that same philosophy. So you can see some of the tiny, tiny hooks we tried. We went to a fisherman's store and bought about as many different kinds as we could get, and then we just tested them. What we came out with was this one. This is a size 6 fishing hook, and we bought out the entire world's supply. We actually cut the tips off of all of these hooks, and it's that tip that's what goes into the point here of the microspine. So no matter what the rock looks like, these hooks will adapt to it and opportunistically grab on.
Wow. So you don't need all of them to hook on. You just need a fraction.
That's right. 10% is all we're looking for. That's actually a pretty strong grip.
The micro-grippers are used on this rock-climbing robot called Lemur 3, which Aaron hopes will be deployed on Mars in the near future.
When you go to the Grand Canyon, you see all those layers in the rock. And if you go deeper and deeper in the canyon, you're going back in time. The same is true on Mars. We've seen this kind of stratigraphy in the rock, but we can't access it. We can only look at it from far away. A robot like Lemur could climb up that Grand Canyon wall, investigating each layer as it goes, telling us the whole history of Mars.
Micro-grippers are the hands for larger robotic arms that will grip and hold an asteroid as the robot drills and collects core samples.
Asteroids are much smaller than planets, so there's almost no gravity. So this needs to work kind of in a free float mode. So the gripper, with all of these sharp hooks here, are grabbing onto surface roughness, little cracks, bumps, pits, ledges on the rock. We can grab boulders that are up to about 4 meters in diameter, something the size of a small school bus or a really big SUV.
So the goal here is to catch an asteroid moving quickly through space, grab onto it, and do what?
So we're gonna learn about it, but we're also gonna change its course. So if it's coming to hit the Earth, it'll be a near miss.
Hard to imagine our world could someday be saved by the same device that catches a trout.